friends, so today we're going to do calorimetry activity. So let me pull my hair back and let's put on our safety goggles. All right, so here's basically the gist of what we're going to do. We are going to heat a piece of copper. I have already measured out the water. We're going to heat this copper. We're going to dump the water into this styrofoam cup. This styrofoam cup is going to act as our calorimeter. All right, then we're going to take the heated copper, put it into the water, and we're going to see how much heat the copper loses. Now, my styrofoam cup is acting as the calorimeter. Now, calorimeters do normally have a lid, so we're going to have to make an assumption here that this, even though it doesn't have a lid, that there is no heat lost to the system around us, to the air around us, okay? So we're going to make the assumption that the heat that gets lost by the copper remains within the water of our calorimeter. So I have measured out 100 milliliters of water, but the reality is I was unable to get it exactly to 100. So I really have 99.9 milliliters of water. Now, why is this important? We want to figure out the amount of heat that has been lost by the copper. Q is going to equal M, the mass, C sub P delta T. All right, now we're not going to be able to measure the copper heat loss because the copper, we don't have a way to measure its actual temperature. So we're going to have to do so by looking at the water. Okay, so we need the mass of the water. Now, if I have 99.9 milliliters of water, the density of water is 1 gram per milliliter. So I can use the density to find the mass of the water. Where 1 gram equals the milliliters, 1 gram per milliliter. Milliliters cancel, leaving me with 99.9 grams of water. So I moved my board out of the way because I'm going to turn on my Bunsen burner and I don't want to catch things on fire. Safety, okay? Let's go ahead and let's get our initial temperature of water. So I have this fancy electronic $20.2. Oh, it just changed. Okay, 20.1 degrees Celsius. Okay, so I just wrote that down so that we have that data. Okay, so now what I'm going to do is I'm just going to let this copper hang in the flame of the Bunsen burner. And we're going to let it sit there until it is red hot. So I'm going to pause the video while this is heating up. And then once it's red hot, we're going to come back and we're going to finish this activity. Okay, so our copper is red hot, which you can see from the video. So what I'm going to do, I'm going to turn off the Bunsen burner. All right. And let's take its new temperature. So I just wanted the copper to sit in there a minute so that we could get the maximum amount of heat loss. Now we're just going to wait for our thermometer to stable out. $25.6. All right. So I can't measure the change in temperature of the copper in order to find the heat lost by copper, but I can look at the water because if you remember, the heat lost by a reaction, in this case the copper, it's not really a reaction, we're looking at copper, so the heat lost by the copper is the heat gained by the surroundings. So the water are the surroundings. So I'm using the surroundings to make my measurement, and then I'm going to apply that to the copper because we are making the assumption that there was no heat loss to the air around us in our calorimeter. Therefore, heat lost by one equals heat gained by the other. And in this case, the copper is losing, the surroundings, the water, are gaining heat. And we know that water gained heat because we see an increase in temperature. So let's find our Q. The mass of water was 99.9 grams. The specific heat of water we know is 4.18. And our units there are joules per gram degree Celsius. And now our delta T, where delta T is final minus initial temperature. So my final temperature is 25.6. And my initial temperature is 20.1 degrees Celsius. So my calculator gives me this value, 2,296.7, and we want to stick to the rule of 3 here. So that's going to be 2,300, but we need to put it, that's only got 2 significant figures. So to stick with my rule of 3 here, I need to put it in scientific notation. So 2.30 times 10 to the third joules. So this is the amount of heat gained by the water. If there was no heat lost to the air around us, that means the heat gained by the water is what the copper lost. Now, this is a positive value. This is a positive value because it gained heat. So the Q of the water is going to equal the negative Q of the copper. We know this is going to be a negative value here because the copper lost heat. Now, in chemistry, remember, a positive and a negative do not tell you the magnitude of the number. They tell you something has either been gained if it's positive or lost if it's negative. And in this case, we're looking at heat. So if my gain was 2.3 times 10 to the third joules, my loss is going to be negative 2.3 times 10 to the third joules, negative because it is lost. Now, if I had chosen to measure the mass of the copper before I did this, we could have then taken our heat loss, put it back here for Q. We would have known the mass. We know the change in temperature. And we could have actually found the specific heat of copper. So there's a lot of different extensions and ways that we can go with this activity. All right, but hopefully this helps give you an idea of what calorimetry is all about.